for lesson 2.3, solving quadratics by graphing. We have this important concept, the solutions of quadratic equations in the form of a times x squared plus b times x plus c equals 0 are called roots of the equation. They are where the graph of the parabola crosses the x-axis. I've written down here, it can have other names. It can be called roots, as we saw here, solutions, or zeros. Anytime you see those three words, we are looking for where the graph crosses the x-axis or where the y value or output is equal to 0. So if we have a graph, right, we are very simply looking for where that graph crosses the axis, right? So right here and right here, right? So we're looking at these 2 points. Our answer is x equals -3 and x equals 2. I caution against writing it like this, x equals -3, 2, because that looks a lot like an ordered pair, right? So if you want to just put it in one, you can put the word and in between, right? Instead of the comma, put the word and in there, just to notify everybody that you know it's two separate x values. So again, you have the graph. It's quite simple, right? We're looking for where the graph crosses the x-axis. So these 2 points here. So my solution would be x equals -2 and -4, or +4, right? Notice I put the word and instead of just the comma. So here we have a situation where they do not give us a graph that crosses on integer values, right? It's between 0 and -1. I could estimate that. If you had the equation, you could be more precise. You'd find the exact value. You can also just say that the roots are located between the two integers, right? So I could say x is between 0 and -1, and again between 4 and 5. Right? So if you have the equation, we can look at being more specific. Here we have an equation, no graph. They ask us to solve it by graphing, and best strategy here would just be to use one of your graphing calculator options, get the data, or even just get the solution or root right from the graph or the table. Right, so I can go into my equation editor here, x squared plus 6x plus 8. Right, I hit graph. I see that it has two solutions. Right, I can see on my graph that it looks like they're at -2 and -4. Best way to confirm that would be go to table. When we're graphing, right, we're looking for the symmetry in the data. So I see that -3, -1 is my vertex. -3, -1 is my vertex. And then I have points here and here, and here and here. Right, so I know that my solution is x equals -4 and -2. And in this situation with graphing, you would want to move the everything to one side of the equation, right? So I would add this 4 across. I would get x squared minus 4x plus 4 equals 0. And then I can type that into my y equals on my calculator or in Desmos, right? X squared minus 4x plus 4. And then in my table, I see just the one solution. Right, so when I graph that up, 2 comma 0, right, so my graph is going to look like this. I see that one solution here at x equals 2. Right, I see that in the picture as well. That's okay. You may have these where you have one solution, two solutions, or even no solutions. For quadratics, those are your three options. And then again, we have a situation where we have an equation that is not equal to 0. So I can just simply add this x squared across. Right, so I'm going to have 0 equals x squared minus 4x plus 1. I put that into y equals x squared minus 4x plus 1. And I see on the graph that I don't have whole number roots or integers for my roots. So in this case, I'm looking for it crossing over from negative to positive or positive to negative. Right? So I see that I have a solution between 0 and 1. And again, right here, looking on my graph screen, between 3 and 4. And again, I see that in the picture. If we were going to use Desmos, we could click directly on the graph. It would tell us the exact values. Your TIs can do that as well. It's a little more work. So we'll look at that another day. So that should bring you up to speed, ready to do your assignment today for lesson 2.3.